Good, welcome to the Alphas Academy. Today we are going to be looking at plane shapes, interior and exterior angles. And here we are mainly focusing on the objectives, the given objectives. We've got the first one being definition of polygons and types or names, some of exterior angles and some of interior angles. Without wasting much of your time, let me dive straight into it. Now, a polygon is known as a shape that has got straight sides. A polygon is a shape that has got straight sides. A polygon is a shape that has got straight side. So that definition sides out or removes the belief that a circle is a polygon. Why? Because a circle does not have straight sides. Therefore, a circle is not a polygon. Right? That's what you can say. A circle is not a polygon. It's not a polygon. Right. So we've got types of polygons. We've got types of polygons that I'm going to dive straight into. We've got types of polygons that I'm going to dive into, and we need to know their names, the number of sides. Probably we can highlight the prefixes, right? The prefixes are the first 4 or 3 letters we write on every name. So I'm going to make some sort of chart or a table if time permits, but I think it is also possible for us to just write that a 3-sided polygon, we start from 3-sided polygons, right, is what, right? But before we look at a 3-sided polygon or types of polygons, rather let's look at the classes of polygons. We've got 2 classes of polygons. We've got regular polygons and irregular polygons. Now, when it comes to naming, we are mainly focusing on the regular polygons, right? We are mainly focusing on regular polygons, right? So you find that for regular polygons, we are simply going to mention only a few names. Whereas to irregular polygons, we've got a lot of names that you can put. So I've drawn a line there so that you can see for regular polygons, excuse me, and for irregular polygons, or irregular polygons. Now, for regular polygons, we say that we start from a 3-sided. A 3-sided polygon is known as an equilateral triangle. Equilateral triangle. Now, when we look at irregular polygons, we are going to find that a 3-sided irregular polygon is known as what? It's got many names, right? It's got many names. We have got probably 2 3-sided irregular polygons that we know. We've got one irregular polygon that has got 2 equal sides and angles, right? We also have got okay, that one we need to name it. What is it? An irregular polygon that is 3-sided, and that has got 2 equal sides and angles, 2 equal angles as well. What is the name that we give to that irregular polygon? I'm sure by now we have managed to answer that. I want to make this lesson as interactive as ever, so I'm going to leave spaces. I'm going to ask you questions. You can answer on your own, right, and then compare with what I'm going to say later on, so that you know what we are really talking about here. So, right, since you have gotten your time to answer that, I'm going to answer for you now. An irregular polygon that has got three sides, whereby it has got two equal sides and two equal angles, that irregular polygon is known as what? Is known as an isosceles triangle. We also have got a three-sided irregular polygon that has got no equal sides at all. No equal sides. So for sides, I'm going to put capital letter S. For angles, I'm going to put capital letter A, right? No equal sides and angles. That irregular polygon is known as a scalene triangle. There are many types of triangles, of right angle triangle, acute triangle, obtuse triangles, but these are what we mainly focus on because these are the most important. Now, with that being said, we can move on to the next type of regular polygons. So I'm going to be cancelling what I've written so that I save time and space at the same time. For a four-sided irregular polygon, we've got what we call, for a four-sided regular polygon, we've got what we call a square, right? A square is a four-sided regular polygon. By a regular polygon, we simply mean that it is a shape that has got equal straight sides. So we can put a square there. We can have a five-sided regular polygon that is known as what? A pentagon. So I'm going to write pent in capital letters, then I'm going to put a dash like that. Pent means five. Pent, and then you finish with agon. Pentagon. We've got a six-sided regular polygon. We call it a hex. Hex means six. Hexagon. We've got a seven-sided polygon. That one we call it a heptagon. Heptagon, right? We've got an eight-sided regular polygon. That one we call it an octagon. For example, you know of an octopus. An octopus has got 8 legs. Oct means 8. So 8-sided octagon. We've got a 9-sided shape. We call them nonagons. We've got a 10-sided shape. We call those decagons. Right? We go on to 11-sided, 12-sided, but we don't really care about 11 or 12-sided shapes when we are doing our IGCSE or O-level mathematics. For irregular polygons, we've got 4-sided shapes as well, right? And when I talk about 4-sided shapes here, we've got a wide range. We can talk of rectangles, we can talk of squares. We can't mention squares now, but we can talk of kites, right? We can talk of rhombuses. We can talk of what else? Parallelograms. We can talk of many examples here, but these are just a few. But from 5-sided shapes, we'll simply be repeating what we've been doing, pentagon, but now it has got a special name. A 5-sided irregular polygon is known as an irregular pentagon. 6-sided irregular hexagon. 7-sided irregular heptagon, and so on. So the most important part is just to know what these look like. So I've talked about polygons and I've managed to name my polygons. This is objective number 1. Objective number 2, we want to look at sum of exterior angles. There's a reason why I was mainly interested in looking at sum of exterior angles first. Is because when you look at sum of exterior angles, it opens up your mind, right? Sum of exterior angles for all sum of exterior angles for all polygons, they add up to what? They add up to 360 degrees. Adds up to 360, not 365, 360 degrees, right? Sum of exterior angles for all polygons adds or add up to 360 degrees. Now, with that being said, you can try and draw any sort of a polygon, right? So I'm going to draw probably I'll start with an easier one, a three-sided polygon. All right, this one is not a three-sided polygon, but it's fine. We're going to look at a regular polygon, right? That one, and it is five-sided, so what do we call it? It's six-sided, so what do we call it? We call it a hexagon. That is a hexagon. If we have our hexagon like that, it's unfortunate I couldn't start with a simpler one, but it's fine. It's still principle. You can play around with it. You can see what I want you to see. Now that is a hexagon. Hexagon is a six-sided shape. Now we're saying the sum of exterior angles, they add up to they add up to 360 degrees. But how do we know? How do we know that these are our exterior angles? It's simple actually. What you do is you continue a straight line. You see this line, this one, where my cursor is at, this one, or let me try and do this. Okay, that line, you simply continue it, right? From the anchor here, or from the anchor, I have continued my line, right? I can continue many lines. From this anchor as well, I can continue my line. From that angle as well, I can continue my line. From that angle as well, I can continue my line. From that angle as well, I can continue my line. Okay, like that. From that angle as well, I can continue my line. Right, do you see something here? If we have continued our lines, we'll get a resultant angle, right? Those resultant angles are important. We've gotten a resultant angle there as well. We've gotten a resultant angle. All right, let me redraw that one. We've gotten a resultant angle like that. We've gotten a resultant angle here. Okay, we've gotten a resultant angle there. All right, we also have gotten a resultant angle here. All right, so these are our angles. This one, that one, that one as well, that one as well, that one as well, that one as well. We call these angles exterior angles. These are exterior angles. All right, we call them exterior angles. I'm going to show them in a different, I'm going to label them in a different color like that, and I'm going to make it a bit bigger. Okay, something like that. All right, now you can clearly see this angle, we call it an exterior angle, right? We call it an exterior angle. Now we are saying principle suggests that sum of exterior angles, they add up to 360 degrees. So if we add that exterior angle that I've labeled and the other remaining exterior angles, we will get 360 degrees. Now according to mathematics, if we can count, we've got 1, 2, 3, 4, 5, 6. So according to mathematics, we can say if one exterior angle is equal to x, let me label that. One exterior angle is equal to x, right? We can safely say that 6 exterior angles, remember we've got 6 exterior angles, so 6 times x, isn't it? 6 times x gives you 360 degrees according to principle. Now we can make x the subject of the formula such that x is equal to 360 degrees divided by 6. Therefore x is equal to 60 degrees. Now with that being said, we can safely conclude that if we've got a given polygon, the sum of exterior angles is equal to 60 degrees, and to find one exterior angle, the sum of exterior angles they equal to 360 degrees, and to find an exterior angle, you divide the sum of exterior angles by what? By the number of what? By the number of sides. The number of sides are equal to the number of angles, isn't it? So we divide by the number of sides. One interior angle is equal to 360 degrees divided by n, where n is number of sides. That is it. Now to find the interior angles, what do you do? Right, we've managed to find the exterior angles. What do you do to find the interior angle? It is very simple. You simply look at the sum of exterior angles, and then you find the one exterior angle, right? That's the long way, but it is the easiest way to understand. And we remember principle that a straight line adds up to 180 degrees. So if you've got one exterior angle, this one that I've labeled exterior angle, to find the interior angle, which is this one I'm labeling now, to find the interior angle, right, you simply have to say 180 degrees. Right, okay, looks messy, but I think it's fine. Okay, to find the interior angle, you simply say 180 degrees minus exterior angle. So principle says that one interior angle is equal to, find one interior angle, 180 degrees minus one exterior angle. That is it, right? That's how you find one interior angle. Okay, which is the most accurate way, by the way, to find one interior angle. But there are many ways to find one interior angle, or to find the sum of interior angles. It's also something that you can do or learn. Now, how do you find the sum of interior angles? Right, let me redraw a simple structure so that it becomes easier for you to understand. We've got a triangle, for example, right? Okay, all right. The triangle has got 3 sides, so a triangle there. All right, there it is, and I'm going to move it here so that you can see it. Right, this is our triangle. It looks as beautiful as ever, as the most beautiful triangle I've ever seen. Now this triangle, it has got and supposedly, maybe if I can just distort it a little bit, because now it is very obvious, but it's also fine. Let us look at that. If I ask you to name that, you tell me that it is an equilateral triangle. without being told, right? Because it looks that way. But it is not safe to always conclude that it is an equilateral triangle. Why? Because if it doesn't have those marks that I'm putting right now, those marks, they show that that one is an equilateral triangle. Those marks here, these ones, they show that this one is an equilateral triangle. Now I'm going to show our angles there, and we know that an equilateral triangle has got equal sides, isn't it? So it means to say one side is equal to the other. An equilateral triangle is also got what? Equal angles. So one angle is equal to the other. Now, to safely conclude the sizes of our angles, or without being told, you also have to see these markings, right? Those markings that I'm putting right now, you also have to see them. They show that these angles are equal. So these are three equal angles. Now to find the sum of interior angles, it is very simple. Sum of interior angles for a triangle, it is very simple. Now in equilateral triangle, rather, we know that it's equal to what? 180 degrees. So every single time you forget about how to find the sum of interior angles, remember the sum of interior angles of a regular triangle, we know that it is always my apologies, I've got flu. We know that the sum of interior angles, they add up to 180 degrees. That's what we should always base on. The remainder, or what comes after, is simply history. Why am I saying it's history? Because we are going to talk about the number of sides minus a certain figure. Now, to make 180 remain 180, where n is the number of sides, right? To make 180 remain 180 in this situation per triangle, on our triangle, what we simply do is ask ourselves, if the number of sides is equal to 3, we subtract 1 from 3 to get 1. We subtract 2 from 3, isn't it? So every time we say 180 multiplied by n minus 2. You just have to fight to make 180 remain 180 for a triangle. And then if you manage to find that, that is the formula for every other polygon. So it's 180 multiplied by n minus 2, where n is equal to, where n is number of sides. Number of sides. Right, that's n. So we can safely conclude that sum of interior angles, or interior total, sum of interior angles for a triangle is 180 multiplied by 3 minus 2, which gives you 180 degrees. That's true, isn't it? Right? We look at another type of a polygon. We are going to look at a pentagon this time. We're going to look at a pentagon. Okay. Now, a pentagon, let's draw a pentagon. Pentagon is 5-sided, so I'm going to draw my pentagon here. It is drawn already. So I will take my pentagon and put it here. Right? How many sides does it have? It has got 5 sides. So n is equal to 5, isn't it? So interior tot, you don't need to be told that. Interior tot is equal to 180 multiplied by number of sides, that's 5, minus 2. I'm sure you get what? You get times 3, that's 540, right? 540 degrees in total. I can also ask you the very same thing that I told you, the sum of exterior angles, they are always equal to 360 degrees. How many sides does it have? 5 sides. How many exterior angles does it have? 5 exterior angles. So to find one exterior angle, you simply say 360 divided by number of sides, which in this case is what? 5. 5 into 6 you get 7, remainder 1. 5 into 10 you get 2. So your answer is 72 degrees for one what? One exterior angle. If you've got one exterior angle, to find one interior angle, if this is assumed to be what? A regular polygon. This happens only when it is a regular polygon, right? Or even when it is an irregular polygon, you'd have found the respective or the corresponding angle to that exterior angle that you have at that particular time. So one interior angle is equal to 180 minus 72, and I'm sure you get 108, isn't it? 108. So you play around with your mathematics like that, and then I think the most important part that I can look at now, is when you are given a polygon that is not equal-sided, right? You are given a polygon that is not equal-sided, and you're asked to deal with it. So I'm going to make this one look unequal. Let me see. Yeah, that one. That way it can look unequal, right? And you are told something. That probably this angle here, this angle there, right? That angle, you are told it's 2x, right? And you are told that, okay, this angle is x, right? That angle is also x here. Alright, so you are told that this angle here is also x, right? And then these two angles are equal as well, right? These two angles are equal as well. Of course, probably you'll be told, right? In this case, they will tell you, they will not keep on giving you algebraic figures. They will have to tell you now, because they will make it difficult for a student. So this one you'll be told it's equal to 73 degrees. 73 degrees, and so is that one here. So that one as well, you'll be told it is equal to 73 degrees. And then you're asked to find x, right? The first thing that you do is you say sum. All right, let me write that one. The first thing that you do is you say sum of interior angles. Sum of interior angles is equal to what? 180 multiplied by number of sides minus 2, right? Okay, I've got my bracket, number of sides minus 2, right? Which in this case is what? 180 multiplied by number of sides, which is 5, minus 2, you get 540. But you are given that the bottom two angles are equal, right? So mathematically you can try and add these angles. 2x plus x, all right, wait, that's not a plus, that's an equal, plus x plus another x plus those two equal angles, 73 degrees plus 73 degrees. You have calculated already, and you have gotten the answer to be what? To be 540 degrees. So you have got 4x plus 73 times 2, that's what? 146 degrees is equal to 540 degrees. 4x is equal to 540 degrees minus 146. This gives you what? 400 minus 6, that's 394. You have 394. Alright, 394 degrees, right? You make x the subject, that means you divide 394 by what? By 4. 394 divided by 4, you get what? You get 4 into 39, that's 9. Remember 3. 4 into 34, that's 8, right? So your answer there is supposedly what? 98.5 degrees. That's what you get. I'm supposing that's what you get. I've done mental work there, but you can use your calculator as well to confirm. 394 divided by 4, yes, we get 98.5 degrees. So for your two angles, the other one which is x, you have 98.5. The other one which is 2x, you get 98.5 times 2. What is it? 197 degrees. And you are done. From there, you can find the exterior angles for the respective angles. For example, the angle that is 2x, the exterior angle is simply what? Something of that sort. But then this one is not mathematically accurate, because if you are getting 197 for an angle there, it is just an example, by the way, but if you are getting 197 degrees for an angle there, it is actually above 180 degrees, which is the angle that is made by a straight line. So if it is above 180 degrees, it becomes obtuse and we might create some problems. But for working purposes, let's stick to probably x, and we are saying x is equal to 98.5 degrees. If x is equal to 98.5 degrees, we can find the exterior angle by saying 180 minus 98.5 degrees. Thank you very much for attending today's lesson. I wish to get you next time.